So in the last video we have seen what are some reasons for inspection and what should be the thought process while developing an inspection plan for different kinds of equipment. So we have seen soil to air interfaces, we have seen injection points, we have seen mixing points, we have seen dead leg inspection, we have seen inspection for various types of damage mechanisms. Now we'll go towards the 8th section of API 574 inspection practice document is the frequency and extent of examination or inspection. So frequency and extent of the inspection will range from often and extensive in the piping classes where the deterioration is extreme, or there is a high consequence to the seldom and cursory in the piping classes in a non-corrosive and low consequence surface. So the extent and frequency of inspection is going to be very high, where the damage rates are very accelerated or the consequence of failure is very high. And it is obviously going to be low for low damage mechanism, or if the damage mechanism is not accelerated, then the inspection interval can also be low. The same thing is going to go on for a very less consequence of failure if the equipment is associated with it. The frequency of the piping inspection shall be determined by the following conditions: consequence of failure, degree of risk, amount of corrosion allowance, available historical data, and regulatory requirements. API 570 requires classifying the piping systems according to the consequence of failure unless RBI is used to determine the piping inspection plan. Each refinery or process plant should review their own piping system and develop either a classification system using the information provided in 570 or RBI analysis. So 570 has given us class 1, class 2, class 3 and class 4. For different classes, what kind of thickness, what should be the interval for thickness monitoring and what should be the interval for the external visual examination is also already laid out. If you use that, you can use that, or you might use risk-based inspection program for identifying the intervals. Either system will help you to establish the minimum inspection frequency for each piping classification or inspection due dates. Some inspection can and should be made while the pipe is operating. Inspection that cannot be made during the operation should be made when the pipe is not in service. Elevated operating temperature can limit the inspection techniques that can be effectively used during the operation. On-stream inspection. So we have seen various kinds of inspection that can happen. On-stream inspection, visual inspection, we have seen supplementary inspection, vibratory pipe inspection, various kinds of NDT that can be applied. So certain kind of external inspection should be done when the pipe is operating. Vibrating swaying is the evident when the process flow through the pipe. Proper positioning and functioning of the support hangers, anchors is most appropriate when the pipe is operating at the temperature, operation at the temperature. The inspector should look for distortion, settlement or foundation movement which could indicate the improper design or fabrication. Pipe rollers and slide plates should be checked to ensure that they operate freely. Leakage is more obvious during the operation. Inspector should look for the signs of leakage both coming from and onto the pipe. Thermal imaging inspection may be performed for various reasons and should be done under the operating conditions. Thermal imaging also shows wet insulation that can lead to COI. Thermal imaging can show breakdown of internal insulatory refractory, which can lead to high temperature corrosion of the piping wall. For instance, radiography can be effective during operation when the pipe is offline. On-stream radiography could detect fouling that might be washed out of pipe during of piping during unit entry preparation. Practical reasons for inspecting on stream. So obviously the reason for the inspecting on stream is going to be that you don't have any downtime. You can identify various process condition while the pipe is on stream. You don't need to shut down the pipe and do this. So when the pipe inspection can be done on stream, can increase unit run length by giving assurance that the pipe is fit for continued service. When the piping must be replaced, on-stream inspection allows the inspector to define the extent of replacement necessary and have replacement piping fabricated before the shutdown. Units are often crowded during the shutdown, and on-stream piping inspection can increase the safety and efficiency of the shutdown operation by reducing the number of people who need to be in the unit during that time. On-stream inspection can reduce surges in workload and thus stabilizing the personal requirements. Offline inspection, when the pipe comes offline or when it comes to shutdown or when the pipe is shut off, and sometimes it may be disassembled. The common limitation to the on-stream inspection is temperature. The equipment used in some kinds of techniques cannot operate at the temperature much above the ambient temperature. In addition, the radiant heat from some piping can be too great for the technician to make measurements safely. In both these instances, the piping inspection may be need to be done when the pipe is not in operation. Signs of wet insulation should be noted when the piping is offline. Water dripping onto the insulation may not show the dampness during the operation because of the heat from the piping causes the surface water to evaporate. But water deeper in the insulation can still cause CUI if the dampness is noted during the shutdown. The damp piping should be considered for the CUI inspection. When piping is opened, for any reason, it should be inspected internally as far as accessibility permits. Some piping is large enough for internal inspection, which can occur when the pipe is offline. Inspection scope. Piping inspection should be frequent enough to ensure that all piping has sufficient thickness to provide both pressure containment and mechanical support. For pipes undergoing uniform corrosion, calculating the corrosion rate and remaining life at each CML and setting the inspection interval at half life and the traditionally given in the quality assurance. The inspector often is in consultation with the corrosion specialist, piping engineers, that has decided the number and location of CMLs. RBI may be used to determine the interval or due date and the extent of examination. For degradation mechanisms other than uniform corrosion, the inspector should determine the type and the type of inspection and the frequency and extent and the location of the CMLs. Corrosion pressure equipment engineers have typically helped in this process. Safety precautions and preparatory work before the inspection. Safety precautions should be taken before external inspections are performed, especially before any piping is opened for inspection. The appropriate personal protective equipment should be utilized for each inspection. Procedures for separation of piping, installation of blind leak testing should be an integral part of the safety practice. In general, the section of the piping to be opened should be isolated from all sources of harmful fluids, gases, vapors, and purged to remove oil and toxic or flammable gases and vapors. Hammer testing of the pressurized equipment may cause failure and allow the contents of the piping to be released. Precaution should be taken before any hammer testing is done for in-service piping, CAPI 2217A. Radiography must be performed in accordance with the applicable requirements of the site and jurisdictional due to potential radiation exposure. Caution should be taken when attempting to remove scales and deposits from the external surface of the in-service piping, especially when operating at high pressure or high temperature with hazardous flammable process fluids. Loss of containment incidents have occurred when the deposits were removed while inspecting for CUI. Support point corrosion, cooling water drifts corrosion, etc. that were covering the wall. Through wall corrosion damage, the owner user may consider the following to mitigate the risk of through wall event. Use Profile RT or use UT non-destructive examination. Develop an emergency response plan in an event that through wall leak develops. This plan should include the provisions to isolate the affected areas, temporary repair provisions, and any additional PPE requirements. Communication before starting the piping inspection or maintenance activities. The personnel should obtain the permission from the operating personnel responsible for the piping to work in the vicinity. When individuals are inside the large piping systems, all personnel working around the piping should be informed that the people are working inside the piping. Individuals working inside the piping should be informed when any work is going to be done on the exterior of the piping. Preparatory work. All possible preparatory work should be done before the scheduled start of inspection. Scaffolds erected, insulation removal, surface preparation completed when required, buried piping should be excavated at the inspection points. All of these things are to be done. All tools, equipment, PPE should be used during the inspection, should be checked for damage or operability prior its use. Non-destructive examination equipment and repair organization equipment are subjected to the owner user safety requirements or for electrical equipment. Other equipment that might be needed for piping system access, such as planking, scaffolding, portable ladders, should be checked for adequacy and safety before being used. The tools needed for inspection should be checked for availability, proper working condition, calibration, and accuracy. The following tools and instruments are often used in the inspection of piping. ACFM crack detection equipment, all of these tools are used. This is a general list, okay? ACFM detection equipment, alloy analyzer, boroscope, fiber boroscope, camera, crayon marker, direct reading calipers, eddy current equipment, flashlight, hammer, ID/OD transfer calipers, infrared pyrometers, knife, leak detectors, magnetic particle testing equipment, liquid penetrant testing equipment, magnifying glass, material identification kit, microwave inspection equipment, mirror, notebook sketches, paint, pit gauge, pit depth gauge, portable hardness tester, radiography equipment, remote television camera, scraper, steel rule, thickness or hook gauge, ultrasonic equipment, wire brush, extra any additional equipment that is needed also should be added to this list. In addition to the above list, grit blasting or comparable equipment may be required to remove paint, protective coating, dirt or corrosion products so that the surface is properly prepared for inspection technique. Investigation of leak. On-stream piping leaks in the process units can occur for various reasons. Those who investigate the leak may be particularly at risk of consequence associated with the leak or with the release of the process fluid. The site may want to create a general safety procedure to be followed during the pipe leak investigation. A further precaution is to hold a safety review before any leak investigation. The review should consider the state of the piping system in terms of pressure, temperature, remaining inventory of process fluid, potential damage mechanism and similar factors. Where the piping may be significantly thinned rather than contain isolated defects, the potential pipe rupture is more likely and should be taken into consideration when investigating leaks or during firefighting efforts. Refer API 2001 for more information on leak response protocol. Safety review team should define hot zone around the leak site and establish a PPE and additional firefighting equipment requirements to perform work inside the zone. Decontamination requirement upon exit from the hot zone and other requirements necessary to protect the personnel and environmental should be reviewed. The safety review team must be careful making the assumptions about the leak cause. Incidents have occurred where investigative personnel assumed that they knew the cause of the small leak on the operating line and were caught unprepared when the leak suddenly became quite large. Okay, so these two sections were pretty similar. In the next section, that is section 10, which is going to be more inspection procedure heavy, so that is going to be most important. It will tell you that how certain kinds of inspection are to be carried out. So we already know how thickness is investigated with the help of UT, but how to do that UT examination will be written in the section 10 of this code. So we'll talk about section 10 in great detail, which is going to be again the most important section of this code. So we'll look at that in the next video. Until then, that's it.